These are my favorite organic chemistry analogies. I love saying electronegative atoms are like thieves. What are they thieves of? Well, they're the thieves of electrons, just like thieves in real life steal money. Electronegative atoms, what do they steal? They steal electrons. And if you get electrons stolen from you, you become electropositive because you lost electrons, so you're approaching cationic. Just like in real life, if you get money stolen from you, well, you're gonna get poorer. Both cases, not ideal. In real life, if you get a bunch of money stolen from you, you might become super vulnerable maybe to attack. That is why the delta plus thing will always be the thing that gets attacked by another thing with the electrons, because it's vulnerable. I'm also a huge admirer of Leo says Jur. Lose electrons become oxidized. Gain electrons become reduced. I think it's weird though how if you gain electrons become reduced, I don't like the person that said the definition or made this up that, oh, if you become reduced, that means you're a good oxidizing agent. If you become oxidized, that means you're a good reducing agent. I mean, I guess it makes sense, but it's just a little confusing. In a high key though, I think my favorite saying has to do with the Cartesian plane and parking spaces. Just so relatable. You say, okay, if two atoms want to make a bond, so essentially, my hair looks crazy right now. If two atoms want to make a bond, the first thing they need to do, well, they need to connect. So that's going to be strong overlap, right? Because, you know, to actually bond with each other, they need to grab each other. That's a sigma bond. So if you think a grab and a hug or a handshake, that's pretty strong. What does it actually look like? Well, it's symmetrical overlap of their orbitals on the bond axis. Now, if you draw out a Cartesian plane, you can think, well, okay, if I look at this like a parking spot, and let's say parking spot X, when they initially wanted to bond, you know, to reach a lower energy state because bonding is favorable, that bond occupied the parking stall. Think in real life, well, if a parking stall is occupied, what are you going to do? Go park on top of the other car? No. You need to find a new parking space. There's only 3 parking spaces here though. There's the X, the Y, and the Z. Let's say these atoms are like, you know what? It'd be pretty favorable for us to make a pi bond. Well, what are they going to do? Well, they need to, you know, over orbitals. This time, the overlap looks a little different because the orbitals can't go in the same area. Just like a parking stall, you can't park in the same parking spot as somebody else. So they can either choose the Y or the Z. So let's say they choose the Z. Well, they have to park on that Z axis, up and down. Oh wait, these orbitals aren't even connecting anymore. They're like perpendicular to the bond plane. Oh yeah, that's a pi bond. So wait, their orbitals aren't even like touching? No. That's why pi bonds are weaker than sigma bonds. You feel me? God, I love chemistry.